Machine learning has many different iterations. So this is basically an iterative process. Now, whenever there is iteration, you have to move forward with some step. For example, let's consider a simple program like this. For example, let's say there is a variable called I equals 0, and just consider a simple loop in a program. Let's say while I is less than or let's say I is greater than minus 10, and you are doing a lot of things inside this while loop, and finally you are doing like I equals I minus 1. So here the while loop, each iteration of the while loop is moving forward in a step of 1, right? So first it started with 0, then it will be minus 1, then it will be minus 2, then it will be minus 3, and it will iterate until it reaches the value of minus 10. So it is moving in a step of 1. Now, since machine learning is also an iterative process, there should be some kind of step size. So in machine learning, the step size is determined by a learning rate. A learning rate is basically a tuning parameter in the machine learning model. Specifically, it appears as a part of the cost or optimization function that determines the step size at each iteration or epoch while moving towards minimizing the loss function. Now, you as a machine learning engineer have to tune this learning rate properly to trade off between the rate of convergence, which is directly correlated with the performance, and overshooting, which means overlook the point of convergence. So what does that mean? What is the meaning of like tuning the learning parameters and trading off between the rate of convergence and overshooting? So let us try to understand it with the simple while loop example like in here. So if you select a very low value for this step in the while loop over here, let's say instead of 1, I am using a step size of 0.00001. So a very small step size. So what is the issue in this while loop? Well, it will start from 0, it will end at minus 10, but this time there are significantly more number of iterations, right? So the process will take a huge amount of time. So the performance can be degraded. So the same thing happen in the machine learning iteration also. If you select a very small value for the learning rate, then the number of iterations will be many more, resulting in a performance issues. So that's one extreme when you select the learning rate alpha as very small. Now, if you select it as very big, then what will happen? Then the other issue, the issue that will arise is called overshooting, means overlooking the point of convergence. So for easy understanding, let us again look at the simple while loop here. So let's say instead of this point 0.00001, this time what you have done is, let's say I just made it like I minus, and then let's say some more values. Let's say I am giving a bigger step size, let's say minus or plus 10 or something like that. So let's say I am using, just instead of doing I equals I minus 0.00001, I am just adding a large, very large value, that is plus 10, or let's say plus 100 or something like that. So what is the problem now? Now, if you look at here, let's say this minus 10 was somewhere the loop was breaking. So let's say this minus 10 was our point of convergence. But since we have given like I as 100, a very large value, it starts from 0, it basically overlooked this minus 10 and it went inside an infinite loop, because every time it is 200, 100 is greater than minus 10, 200 is going to be greater than minus 10, 300, 400, and this way it is just going into an infinite loop instead of reaching the point of convergence where it can break. So the same thing can happen in machine learning also. So there is a point of convergence. Let's say it looks something like this, the cost minimization function. So this is, let's say, the plot of the cost function. Here is the minimization point. Let's say the first time you got into this point, then second time you got into this point, in the third epoch you got this point, in the fourth epoch you got this point, fifth epoch you got this point, and then in the sixth epoch you got this point. So like this. So if you select kind of a very small value starting from here, if these small gaps are very small numbers, then reaching this point will take more time. On the other hand, if you take like this type of values, let's say this is my first epoch cost function, and you set the learning parameter in that way, then the learning parameter is set like so that it incremented in a larger step, and then after two iteration it just overlook this entire point and started going in this direction. So it will never converge and it will go inside a infinite loop. So the machine learning algorithm uh, will never complete and cannot produce any model. So that's called so that's the value of, or the value of learning rate, and that's what you as a machine learning engineer have to adjust and trade off to keep up the good performance while uh, achieving the minimum point also.